Hello everyone and welcome back. So let's try another one. And we have a solid stainless steel shaft with a shear modulus of 12,500 KSI. It's 72 inches long and subjected to a pure torque of 900 pound-inches. So first off, everybody, boo English units, boo. But I have to throw them at you to make sure that you're prepared. Because only 3 countries in the world use them. You're currently in one of those countries. Okay. So what do we want to find? Well, we want to find the minimum diameter required if the shear stress must not exceed 8,000 psi. And being keyword here, and the angle of twist must not exceed 5 degrees. Okay, and so what we want to know is we're going to find the minimum diameter, and we're going to figure out what the shear stress and angle of twist are at those points. Now, it might be that at 8,000 psi, we just reach 5 degrees. Fantastic. Or, which is more likely, we'll reach one or the other first. So, we'll have to guess which one it is. So, as always, pause, go try it out, see how it goes, and then you come on back here and tell me how it went. So 3, 2, 1, and you're back. Let's try it out together. So, like last time, let's calculate that polar moment of inertia first because we're going to need it for everything. That's simply going to be pi over 32 times the diameter to the 4th, which if I plug that in, I can now put that into my elastic torsion formula because I'm solving for the diameter. Don't know what it is yet. Now, when I do this, you're going to see that I'm going to be able to cancel, so I'm not going to be d cubed. And it's going to be equal to my torque over my shear stress. And from this, I can then solve for my diameter. It's a function of the torque and shear stress. This will be the max shear stress right here. Okay, now with that, we can finally start to calculate the minimum diameter that's going to satisfy our allowable shear stress. When we plug that in, we get our diameter has to be more than or equal to 0.831 inches. Just be very careful because this is pound inch right here. So we had to switch from KSI to PSI right there. It's a little bit difficult with those prefixes when you're in English units rather than in our metric units. Now we could just sit here and hope and say, you know what, I just think this is going to be the best one. But as you're probably guessing, since I made this example, I've done this one first, this is actually not going to be the parameter that controls our diameter. So we're going to have to also look at and see what the diameter would need to be for the angle of twist. So let's check that out. Now for our angle of twist equation, we have phi is equal to the torque length over the polar moment of inertia times our shear modulus. And then if we plug in everything we know, we can gather terms and realize that when we plug everything in here, do a little bit of algebra, our diameter would have to be more than or equal to 0.882 inches. 0.882 inches. So this is going to be controlling the diameter. Another thing to be thinking about is the following. 1, we had to go from mega psi or to psi right here. I think it said 12,500 KSI, but you know, we had to go straight to psi. Second, we couldn't just use 5 degrees. We had to change that to radians. There are pi radians and 180 degrees. So be careful with your conversions. Remember, we never, ever, ever use degrees in an equation. Always radians. Always radians. Radians are physical. Degrees are just a way of us talking about things. Now, since we know what the minimum diameter is going to be now, we can go back and calculate the shear stress and the angle of twist. The angle of twist is easy. We already know that because it's 5 degrees. That's what's controlling this. What's going to be the shear stress at this particular point? Well, we have to calculate our polar moment of inertia again, which is going to be 0.882 inches to the 4th times pi over 32, which is 0.059404 inches to the 4th. If we plug that into our shear stress equation, being very careful with our units, we'll get 6,680 psi as our answer. So that's it. Remember, for all these questions, if there's 2 conditions and you have to meet both, and it says and, make sure that you check both before you make your decision and start doing all those numbers. Otherwise, you're going to have a bad time. So, thank you for listening, and I'll see you all next time.